So we are moving towards details of Bohr model. And in Bohr model, we learned when an electron falls from a higher orbit in energy, when an electron falls from a higher orbit to a lower orbit, energy is emitted. Emitted energy, we can take the photograph. That photograph is called a spectrum. Photograph, the word spectrum is used for a photograph in chemistry and physics. We say photograph, photograph, photograph. In chemistry and physics, that is a spectrum. When you take the photograph, see the light what is coming from our hair, that is black, nothing. So there it is black. From different parts, if I take the photograph of this, see the chalk portion is sending the light. That light is captured by the camera. So the light emitted is captured. The light emitted is captured. If you take a photograph in dark, nothing will be seen. In night, if there is no light, nothing will be seen. Photograph will be empty, black. Only in light you can take the photograph. At night, they flash, they put the light and the emitted light. They put the flash and the emitted light is captured. So emitted light is captured and that photograph is called a spectrum. And when they take this spectrum, they get many information from that photograph. When an electron falls from a higher orbit to first orbit, when an electron falls from a higher orbit to first orbit, some amount of energy is emitted in the form of light and that is captured. So they get one line in their photograph. And if an electron falls from another higher orbit to the first orbit, something else is also in that photograph. There are so many atoms in hydrogen gas. If you take hydrogen gas, hydrogen molecules are there. When it is heated, this molecules break into atoms. So many atoms per atom, one electron. So many electrons in one atom. The electron may be falling from that orbit to this. Let this be 1, 2, 3, 4, 5, 6, 7, 8, 9. So in different atoms, these different electrons, excited electrons means electrons at a higher energy level. If the electron is on the first orbit, we say ground state of hydrogen. If electron is in the first orbit, we say ground state. And other states are called excited states. Excited state. If electron is present here, it has got some amount of energy associated with it. If electron is on third, a higher energy in that electron, or if it is on the fifth, again a higher energy, sixth, again higher energy. Energy of the electron is increased if it is on higher orbit. If it falls to a lower orbit, energy is emitted and it will be having a lower energy. It will be having a lower energy. Whenever the electron falls from higher orbit to lower orbit, some amount of energy is released. Energy. Shriman Dwivedi. All right. You enter with your audio. Turn off your audio. Turn off your audio. Then I have to mute. Okay. Otherwise, I have to mute all. Mohak Jain. Get it. So emitted light can be photographed. So in a photograph, you will be getting many lines. When the electron, suppose the electron in one atom, the electron was on that orbit 9th. And when it falls to 1, you will be getting a line. From 8 to 1, from 7 to 1, from 6 to 1, from 5 to 1, 4 to 1, 3 to 1, 2 to 1. So you get a group of lines, a group of lines. Lyman, scientist Lyman visualized this thing, he observed, and he named it as Lyman series. These series of lines are called Lyman series. If it falls from a higher orbit to second orbit, this what I have shown is first orbit. If it is on the second orbit, Balmer observed, so we call it as Balmer series. This is the only light which is visible to our eyes. This emitted light we can see. Others are either IR or in UV region. Only this Balmer series is visible. This light we are able to see with our naked eyes. Now I am going to show from higher orbit to this third orbit. This series, third orbit, this series was observed by Passion series. This is Lyman series, Balmer series, Pascal series. Next is bracket series on the fourth. That is bracket series. Bracket. Scientist bracket, surname is bracket. Bracket series, BRACKET, bracket series. And see, this is on the first, second, third, fourth, and on the fifth. This is fund series. P PFUND, fund series. Lyman series, Balmer series, Pascal series, bracket series, and fund series. So this is an emission spectrum. By getting this photograph, by looking at the photograph, you can talk about the structure of an atom. So these are the emitted lights. Emitted line. You get one line for when one light is emitted, we are capturing that line, and you are getting this spectrum. This is called line spectrum. The photograph I'll show. These are the emissions taking place, and the photographs will be in this format. N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, N is equal to 5, like that. From higher orbit to N is equal to 1, like this. This is Lyman series. From higher orbit to N is equal to 2. Balmer series. From higher orbit to N is equal to 3. Pascal series, bracket series, Fund series. All right. So this is the photograph we have obtained. But when when highly powerful spectroscopes were used, it was seen that each line is a combination of several lines. That is called, means very fine lines. One line is made up of very fine lines. Using a powerful spectroscope, if I look at this one line, it is made up of many lines, very fine lines. That is called fine spectrum. This is emission spectrum. That is called fine spectrum. F-I-N-E, fine spectrum. All right. So electron in each orbit has got a particular amount of energy. Electron in each orbit has got a particular amount of energy. If it falls from that orbit to a lower orbit, energy will be emitted. If it moves from a lower orbit to higher orbit, energy will be absorbed. Now, look at this hydrogen atom. Two things you have to learn about one atom. One is radius and one is its radius of the orbit in which electron is present. Sarab is unable to enter. Radius of an electron, radius of that orbit where electron is present. For example, if electron is present, this is the radius. This radius is called Bohr radius. Bohr radius. If the electron is present here, then the radius of that orbit, that is higher. What about its energy? Energy will be higher. If the electron is present here, radius of that orbit is again increased, means energy of that electron is increased. Write down the radius of Bohr orbit, B-O-H-R, Bohr orbit is 52.9 picometer. This is 52.9 picometer, Bohr radius. So that is the smallest radius. Bohr radius is equal to 52.9 picometer. Other radii means higher orbits radius, that radius is given by, this is known as A naught, n square A naught upon Z. N square A naught upon Z, where Z is the atomic number and N is the orbit number. In the case of hydrogen, Z is equal to 1. General, for other atoms, N square A naught upon Z. That is the radius. So, What is Z? Write down. Z is the atomic number. Z is the atomic number. If it is helium, if it is helium's first orbit, n is equal to 1, Z is equal to 2. If it is lithium's first orbit, n is equal to 1, Z is equal to 3. Z is the atomic number. And what is the energy of each electron? Energy of an electron is given by, so energy of an electron, that is, which is the highest energy? That is 0. Highest energy means in the infinite. In this atom, if you consider the highest energy, that is 0. When you come down, come to the inner shell, it becomes more and more negative. So inside an atom, energy will be having a negative. Energy of an electron will be having a negative sign. So that energy is equal to minus. Inside an atom, there will be a minus because infinite level, that is 0. Minus 2.18 into 10 to the power minus 18 Z square upon N square. This is the energy of an electron. So what is Z square? Z is this atomic number. Write down. Z is equal to atomic number. Minus 2.18 into 10 to the power minus 18 Z square upon N square. Previously, in the radius, N square was on the top, Z was down, radius. And in the case of energy, N square in the denominator and Z square on the numerator. ये उल्टा है. R is equal to N square A naught upon Z, where A naught is the Bohr radius, that is 52.9 picometer. Energy, that is minus 2.18, it is called RH. It is called RH. RH is equal to, so I can write it as minus RH. This is RH is this value. Z square upon N square. RH is called the Rydberg's constant in terms of joules. Rydberg's constant. In terms of centimeter inverse, there is another value that we will see. Okay, RH, that is Rydberg's constant. RH is equal to Rydberg's constant. So energy of an electron in the infinite shell, that is 0, then minus, more minus, more minus, more minus, more minus, more minus means the least energy is in the first orbit. Least energy is in the first orbit. As you go up, energy is increasing. So higher energy minus lower energy will be having a positive value, amount of energy absorbed. Higher energy minus lower energy. Higher value minus lower value. What is higher value? Higher value means less negative. Lower value means more negative. Right? Energy, if it is emitted energy will be having a negative sign, and absorbed energy will be having a positive sign. Now, write one question. Calculate the energy associated with the first orbit of He plus. He plus means one electron system. Bohr atom model exists only for one electron system. So calculate the energy associated for this electron present in He plus. Calculate the energy associated with the first orbit, that is n is equal to 1. N is equal to 1. What is the radius of this orbit? So two things you have to calculate. Energy of the first orbit. If the electron is present in the first orbit, what is its energy? So energy is equal to minus 2.18 into 10 to the power minus 18 Z square. Z square means 2 square. Helium, it is helium 2 square. And first orbit, that is 1 square. Do the calculation and tell me the value. Minus 8.72 into 10 to the power minus 18. Minus 8.72.
अरे वीडियो तो ग्राम में मेरे को पता है ना, मैं अटेंड कर रहा हूँ।
Parth Sony, mute yourself. Parth Sony, mute yourself. All right. Okay. Minus 8.72 into 10 to the power minus 18 joules. What is the radius of this orbit? What is the radius of this orbit? In the case of hydrogen, we know 52.9 picometer is the radius of that orbit, first orbit of hydrogen. What about in helium plus? Helium plus again 1 electron system. Radius is equal to first orbit 1 square, n square a naught upon z, that is 2, that is 26.4 picometer. It was, in the case of hydrogen, it was 52.9, now it is 26.4. So helium ka 1 electron is more closer towards the nucleus as compared to hydrogen's 1 electron. Helium's 1 electron is having lower energy as compared to hydrogen's 1 electron. These are the informations that we are getting from this equation. What is the radius of electron of that orbit in hydrogen? 52.9 picometer. In the case of helium's 1 electron, it is more closer towards the nucleus, that is 26.4. If it is more closer towards the nucleus, energy will be less. You see, in the case of Parth Sony, better I mute. You consider hydrogen's 1 atom and you consider hydrogen's 1 electron. You consider helium plus 1 electron. One species is hydrogen atom, one species is helium plus species. Helium plus is not an atom, it is a species, it is a positively charged ion cation. So hydrogen atom has got 1 electron, helium plus has got 1 electron. Which electron is more closer towards the nucleus? Helium plus, because radius is only 26.4. In the case of hydrogen, it is 52.9. Since it is more closer towards the nucleus, its energy is again lesser. What is the energy of this electron in helium plus? We have calculated minus 8.72 into 10 to the power minus 18 joules. You calculate the energy of that hydrogen's electrons in the first orbit. That is E is equal to minus 2.18 into 10 to the power minus 18 Z square upon N square. There Z is 1. So the value will be minus 2.18 into 10 to the power minus 18. Here it is minus 8 point. There it is minus 2 point. Here it is minus 8 point. That means minus 8 is a lower value than minus 2. Minus 8 is a lower value than minus 2. So energy of this helium plus electron, that is lower than that of hydrogen's electron. See, minus 8, there it is, minus 2. Okay, that's about energy, and these two equations you have to by heart. That is the radius equation. Radius is equal to n square a naught upon z. N square a naught upon z. E value minus 2.18 into 10 to the power minus 18. Z square upon n square. Z square means atomic number square upon n square, that is n square, that is orbit number. Next question. In which case electron is more closer to the nucleus? In which case electron is more closer towards the nucleus? I am giving you H, He plus, Li2 plus, Be3 plus. Once again, H, He plus, Li2 plus, Be3 plus. Just now we have seen H and He plus. In He plus, it is more closer towards the nucleus, means you have to calculate the radius only. You see the radius. Radius is n square a naught upon z. Z is coming in the denominator. So Li2 plus Z bigger. Be3 plus Z again bigger. Be3 plus Z again bigger. So in the case of Be3 plus, the electron is more closer towards the nucleus. So you have to explain using radius equation, or you can use energy equation. Radius equation is easy. So you can explain this using the radius equation. So explain using equations for R. R is more closer, radius, more closer, n square a naught upon z. And in all these cases, only one electron is there. Only one electron is there. In which case, electron is more closer towards the nucleus. If it is not told in which orbit it is, you have to take it as first orbit. Okay, first orbit of helium plus, that is more closer towards the nucleus, first than hydrogen. First orbit of Li2 plus is more closer towards the nucleus than He plus. First orbit of Be3 plus is more closer towards the nucleus as compared to Li2 plus. So in the case of Be3 plus, electron is the most close here. Closest is in the case of Be3 plus. All these species are having one electron. Okay. Inside an atom, each and every electron will be having an energy with a negative sign. Next heading, you write negative sign of energy. Negative sign of energy of an electron inside an atom. That we will see tomorrow. Thank you, all of you.